Are you ready to find out kind of what the next piece of this puzzle would be? Now, the puzzle is analyzing a function. Just so you realize, you just finished a quiz in a section on analyzing for extrema. Okay, you're basically doing some simple thinking about slopes to help you determine if you had a max or min. There was also some endpoint thinking. It looks like overall you guys have the idea. Sometimes we still need to clean up some algebra, but that happens. So what's this little secret? What's this little connection? Okay, well, it starts with an S. What word starts with an S that seems to be pretty popular these days? You got to kind of think about this class, of course. Slope. Okay, slope. Now, you already know that the slope equaling 0 is a big deal. Because remember, when the slope is equal to 0, well, that's why you have maybe like a maximum, or that's why you have like a minimum. But what about the other slopes up here? Let's talk about them. Let's talk about the slopes, the other slopes on this f of x. Now, you might feel like that you've heard some of this because I actually said it on the very first day, but again, research shows that it's helpful to say it a couple times. So think about this slope right here. Maybe you already know what I'm going to say, but the slope in that green section and this green section, just so you realize that they both would have the same conclusions. Simply, the slopes are positive. We have positive slope. Again, in both of those green sections. Now remember, positive slope means that the line is tilted in a positive way. It also means that the graph is going up. Sometimes kind of like these little up arrows can help to think like that. And it also means that the derivative. Now remember, when I say derivative, you say slope. So when I put the word derivative up here, or if I put the symbol f prime of x, that still means that I'm talking about the slope. But we get a little fancy, and we can say that the derivative is greater than 0. Now, to say the derivative is greater than 0 is simply to say that the slope is positive. It's just using some notation. What else do we notice? We're not quite ready to answer the question up there, but we're still noticing some slopes. And I hope that you notice that we have some negative slope. We have some negative slope. That, of course, means that the graph is going down. And these little down arrows kind of help you to see that. But definitely the graph is going down. It also means that the slope is tilted in a negative way. And it means that f prime of x is less than 0. Now try not just to be kind of like vegging out. Try to be thinking. And when I write f prime of x, if you're really thinking, when I write f prime of x, you're saying to yourself, oh, he's just talking about the slope. Because remember, the derivative is the same as the slope. And when I say less than 0, of course, that also means negative. So it's just a little different way to say it. Now, you're going to learn that you can take this two-dimensional graph. You're going to learn that you can take this two-dimensional graph and you can summarize it with a one-dimensional number line. Now, a one-dimensional number line takes the key parts of this graph, which make sure that you realize that A and B are definitely the extrema. But the slopes off of this graph can be summarized on this simple number line with plus and minus signs. Now, I hope you realize that I'm kind of saying the same thing. I'm just trying to summarize it. I'm trying to simplify it. And also understand that this number line I'm putting down is a slope number line. Because it really is all about the slope, the slope, the slope. So why is it all about the slope? What's the big deal? Well, I'm thinking it would be better if I talk about that after lunch, but we're just like right there. So make sure you realize where we are. We're about ready to make a connection between these slopes and these extrema. Okay? We're about ready to make a connection between those slopes and the extrema. You just have to wait 30 more minutes to hear it. Okay, are you ready for this big reveal? Okay, now I kind of hope you're looking at the stuff that's up here and saying, all right, I got this, Mr. Naylor, but just to make sure you get it, slope is positive, graph is going up. Slope is negative, graph is going down. And then, of course, it's positive again. So what does this have to do with extrema? Basically, how do the slopes that are changing tell us if we're going to have a max or min? Now, you actually should kind of look at this and say, oh my gosh, of course. What's the of course? What happens when a slope is positive and then switches to negative? I mean, what would have to happen every time that a graph goes up and then a graph goes down? Well, it would have to be that you just passed a maximum. If you just think about it, there's no other possible thing that could be true. So a positive slope switching to a negative slope has maximum written all over it every time. A negative slope, in other words, a graph that goes down, switching to going back up. Again, every time you picture something that goes down and then goes back up, every time you have negative switching back to positive, it has minimum written all over it. And so we're going to use the changing slopes. We're going to use the changing slopes to officially identify extrema. And what I showed up there is supposed to make it simple, like a simple graphic. But I also want to give it to you in words, but I don't want to overcomplicate it. So you decide what you want to write down here. It's the same thing that we said. Again, you decide if you want to write it down. Make sure you realize that I'm talking about the slope switching from positive to negative. So if a slope is positive, but then it switches to negative, well, you'd have to have passed a maximum. And then it's just the opposite. If it's negative, but then positive, then you would have passed a minimum. Now listen, I'm not big into memorizing things that you don't have to memorize. This really should be one of those things that if you just picture it, and we're going to picture it, okay, a couple times, more than a couple times. But if you just picture it, you should always come up with this conclusion. And this number line is really going to help us with this. Now, I got to make sure that you catch my drift here. This number line is not babyish. It's also not something that is sort of optional, but it actually becomes like the work. It becomes the way we organize the work. It becomes the way we make our conclusions. Like, we're going to use a number line. And I haven't shown you really how to use it, except that we can put slopes on it. But I do want you to notice right now that the A and B that's on this number line aren't just random. The A and B are the extrema that you would have found in the last section. So one of the cool things about this number line is that it uses what we did already, that is, uses the extrema, but we're going to add to this the slope. We're going to add basically positive and negative. To kind of help you become a believer in the number line, I want to do kind of one more intro problem where I give you a number line and some other information. And I just want you to realize how helpful this is and basically how you can use the number line to create some conclusions. What we want to do here is we want to try to figure out what's a maximum, what's a minimum, just so you understand that's kind of still the goal. But we're going to use this number line to help with it, help do it. I want you to picture this, and I'll be honest, I still picture all this stuff. Okay, it's not like I just kind of do this from memory. Like I'm picturing right now a graph that's going up. Now, sometimes kids are like, "What graph?" Well, any graph that's going up. You almost have to just put your pencil to the paper and realize that I can start going up. Okay, especially when you draw it, it becomes very clear that if I'm going up because I have positive slope, but then I start going down because I have negative slope, okay, well, what has to be true? Let's kind of put this all together. Okay, there's some other information that's given here, like -3 matches up with -7. Now, that would mean that this point right here is -3, -7. And then what else do we have? We have 4 goes with -1. That would mean at this point is 4, -1. Now, kind of the weird thing about this graph is that there's no x and y axis. And yeah, it's kind of weird. We just kind of have a graph drawn. But it's okay. I don't need an x and y axis to be able to show something that goes up and then to show something that goes down. And to be able to make a pretty obvious conclusion. And that is that -3, by the way, -3 is actually an endpoint. Do you notice it's an endpoint because I have no slope over here? So that means that there's no graph over here. So -3 is an endpoint, and it's definitely a minimum. And then, of course, since we switch from positive to negative, as we can already see, that 4 is definitely a maximum. And my whole point behind this is that it's all about the slope. It's all about the slope, the slope, the slope. Okay, and this number line basically organizes that. Now what we're going to do is we're going to have an equation like usual, and we're going to use the derivative as we've done, but we're going to put all this stuff on a number line. And let me show you how we can do that. Well, first let me actually give you, I like to actually kind of give you this process. I think a lot of it will be natural for you, but I still want to show you this screen. And if you want to jot it down, that's fine. I'll be quiet. If you just kind of want to read it, it is going to become a pretty natural thing for you guys. Look at the steps. Hopefully you're looking at it, even if you're writing it. you still find those critical points. That's actually what you just spent the last section doing. But we're going to take those critical points, we're going to put them on a number line. Now, it's step 2 that will kind of be the new idea, and I'll show you what I mean by that. You're going to do some evaluating. You're going to do some evaluating between the corner points. Okay, and that will eventually become like a no calculator type evaluation. So step 2, that's the big one. It should be pretty easy to make your conclusions. We've actually made those conclusions a couple times already. All right, so we've got a function. You'll look back at this problem and say, this is a pretty easy function. But I want to start with, actually on purpose, something like that. So we've got negative x squared plus 4x. We're trying to analyze it. We're trying to analyze it for its maximums and minimums. We're also going to analyze it, if you saw up here, for what's called increasing and decreasing. But just so you realize, that's basically the number line. Okay, but we're going to give this kind of the works. We're going to give it the works. Okay, and it all starts with a derivative. Remember, this is the derivative application chapter, so yeah, you're going to do the derivative. I just want you to realize the reason you're doing the derivative is because it's all about the slope. In fact, it is the slope. So when you get negative 2x plus 4, you're getting a slope formula. Now, according to step 1, we want to find the critical points. I don't think you'll forget this because it's where it all started. The critical points are always when the derivative is equal to 0. So again, the same thing that you just got done doing numerous times in your assignment. Okay, not supposed to be a hard equation, but please solve it carefully so you get x equals 2. Okay, now x equals 2 is a critical point. So here's the part of the process that's kind of new. You're going to take that critical point of x equals 2, and you're going to put it on a number line. Now, it's a derivative or slope number line. It doesn't hurt to label it like that. Now, here's what the number 2 does. Quite simply, it divides your number line. It divides also your slopes. In other words, there's going to be some type of slope to the left of 2, and there's going to be some type of slope to the right of 2. And this is where we get into step 2, where we're going to do like a little bit of evaluating. Now, you got to understand that all I need to do is pick some number on this side of 2. It can be any number you want. Choose wisely, like 0 if you can. The reason that you'd want to choose 0 if you can is because it's really easy to plug in. Now, I'm going to plug it in to the derivative. Sometimes you'll do this mentally. Sometimes you'll have to think a little bit more. Eventually, you'll do this without a calculator, all the time. But make sure you realize I'm plugging in right here. Okay? Negative 2 times 0 plus 4. I'm plugging into the derivative. Why am I doing this? Okay? I want to see what the slope is at 0. And it looks like that the slope is positive. It's positive. Whoops. I can do math. It's positive 4. Okay, but the emphasis here is that you end up with a positive slope. Okay, and that means that every slope on this side of 2 is positive. Again, did you catch that? Every slope is going to be positive. I don't have to worry about using another x value. But I can, and I should, check out what's going on over here. Okay, now again, I just need to pick a point on this side of 2. You can pick any number you want. I just don't want you to think it has to be 4. It could be 5. It could be 100. It could be the number 3. Okay, but what you do is you plug that in to the derivative. You plug that into the derivative. So I plug in 5. I do a little bit of simple math. But actually, the most important thing is that you conclude that it's negative. That means the slope is negative. That means the number line is negative. And it now means that we have the ability to analyze this function. Now, here's what I want you to do every time. I want you to picture a graph that has a positive slope. So a graph that goes up. And then it has negative slope. So it goes down. And whether you draw it or you just picture it, but every time you do that, you're going to come up with the correct conclusion. I hope that that conclusion would be that this critical point is a maximum. This critical point is a maximum. And now we just kind of want to organize our answer. Now, when you guys give these answers on like a test or quiz, I'll probably have some lines. When you're doing it on an assignment, you can decide. But a lot of students will make like a box, or at the bottom of the problem, they'll do something to kind of get this all organized. First of all, the extrema, well, there's only one. It's x equals 2. It's a max. Now, just like you did in the last section, you still need to get the y value. Sometimes kids will say, do I have to do it? Yeah. And I know it's one extra step, but you need to plug 2 back into the original equation. And again, in the original equation, be careful with that because it's going to be negative 2 squared plus 4 times 2. Make sure you're squaring 2, and then you're putting a negative sign on it. So we get negative 4 plus 8 comes out to be 4. Again, make sure that you're squaring 2 and then putting a negative sign on it. That would be the order of operations. Okay, it's kind of the same thing we've done, but we did it a new way. What's this? What's this increasing? Well, increasing just means that the graph is going up. Oh, we kind of already figured that out. The graph is going up on the left of 2. In other words, the graph is going up when I have positive slope. Okay, now I just want you to say that. Like I want you to look at your number line and say, okay, it's increasing when x is less than 2. And by the way, if you want to give that answer as an interval, like negative infinity comma 2, that's fine. Okay, you can write the answer how you want. And then what's this decreasing thing? As you probably can guess, that's the negative slope. And it's everything to the right of 2. X greater than 2. Or you could say 2 to infinity. What about the graph of the derivative? We found the derivative, negative 2x plus 4, but let's take a look at the graph of the derivative. There's an interesting connection that I want you to start to make, and sometimes just showing you is the first step in that connection. Now, notice what I'm graphing. I'm graphing negative 2x plus 4. Again, that's literally the derivative. Okay, now if you graph negative 2x plus 4, well, it's actually not a big surprise what you get. You get a line, and it happens to be a line that has a slope of negative 2 and a y-intercept of 4. But what does it really show us? What does this line really show us? Well, the answer is slopes. In fact, it actually shows you the same slopes that we already discovered on the number line. I just want you to be able to see the slopes. See the positive slopes, because these are positive y values. See the negative slopes, because these are negative y values. Now, do you get what's going on here? These plus signs refer to the value of the graph, which is exactly the same as the slope. These negative signs refer to the value of the graph. Again, that's the same thing as the slope. So we can actually have the derivative, the graph of the derivative, helping us to understand the graph of the original function. Sound a little bit like the slope investigation that you did about a month and a half ago. Well, it's exactly the same idea, where we're going to be able to use graphs to also help us analyze those slopes. Now, it's good stuff, but let's also kind of come back to earth a little bit here and realize that even back in Algebra 1, it would have been like at the end of Algebra 1, but in Algebra 2, you guys would have said, hey, wait a minute, this is just an upside down parabola. Yeah, this has been an upside down parabola since I wrote it on the board. But calculus slopes give it kind of the full course and tell us, well, the same thing. But the nice thing about calculus and slopes is it allows us to get into some much more complicated equations, maybe equations that have more twists and turns, and even other things that I'm going to show you next time. But this is the little secret. And again, the secret is the slopes, which is summarized in this number line.